Good afternoon, everyone. Today we're going to do a video on subtracting mixed fractions. And once again, much like we did with the adding mixed fractions video, we're going to discuss two different strategies and when they are most optimal to be used. Now, our first example, we have 3.5 minus 1 3/4. And so these numbers are still fairly small relative to our second example where you see we deal with much larger numbers. And so I'm going to opt again for example 1 using improper fractions. And so we'll convert our mixed fractions into improper fractions, okay? Write that explicitly. We're converting our fractions into improper fractions, and remember how to do so. We multiply our whole number by our denominator, so 3 groups of 2 plus 1 additional in the numerator gives us 7 halves, and then taking away 1 group of 4 plus 3, 7 quarters. Now we want to subtract fractions that we always have. So that's the nice thing with converting to improper fractions. It's one more step of work, but now we're right back into our subtracting two fractions kind of question, which is something hopefully you've had quite a bit of practice with. We think to ourselves, what would our common denominator be for 2 and 4? Our common denominator, which we always need to add or subtract rational numbers, would be 4. And so 7/4 can remain the same. 7 halves, we get our equivalent fraction by multiplying by a scale factor of 2, and we multiply always the top and the bottom. And so 7 times 2 gives 14 quarters. And now, with our common denominator, we can subtract 14 minus 7, giving us a solution or an answer of 7 quarters. If you want to practice converting back into a mixed fraction, 7 quarters, 4 goes into 7 once. 1 group of 4 is 4, so it counts for 4, and so of the 7, there would be 3 quarters left over for a mixed fraction of 1 3/4. Now for number 2, we're going to opt to subtract the whole numbers together and then subtract the fractions together. However, we know that the mixed fractions are made up of a whole number along with a fraction, and so we're going to have 45 minus 36 for the whole numbers. We're going to have 3/4 minus 4/5, but we're still putting them together in the end. So it's important to remind ourselves that we're still adding them together back at the end, right? Because this is 45 plus 3/4, we have 36 plus 4/5, and so we still need to remember to add them at the very end, okay? Now we can go ahead, like we're used to doing. 45 minus 36 leaves us with 9. And now we're back to we're back to subtracting two fractions. We have our denominators of 4 and 5, and so what might our common denominator be? Now we're back at the step of finding our common denominator, which we always have to do. So for 4 and 5, the smallest number that is both the multiple of 4 and the 5 happens to be 20. And so to get our equivalent fractions down below, we think 4 times what brings us to 20? 4 times 5. And so we want an equivalent fraction, and so we always do the same to the numerator up top. 3 times 5 is 15/20. And likewise for the 4/5, we want to scale factor it to become a 20th. So 5 times 4 gives us 20ths. And to get an equivalent fraction, 4 times 4 is 16. And so you might wonder how we're going to deal with that situation at the end there. So now we'll have 9 plus, let's keep this in brackets, 15/20 minus 16/20, giving us quantity of negative 1/20, okay? And this is a beautiful segue into discussing how we add negative quantities, negative numbers. Adding a negative number is exactly the same as subtracting that number. Again, I'll say it again. Adding a negative quantity is the same as simply subtracting that quantity. This is something we see a lot in grade 7, grade 8, grade 9. And so we can write this equivalently as simply 9 minus 1/20. Okay? And now, if we have 9 entire units and we take away 1/20, then we're left with 8 and 19/20 in the end. Okay? And so there we have it. Now, if we were to opt to use our strategy where we convert to improper fractions, like we've done in example 1, we could still definitely do that. We're simply dealing with much larger numbers, and so our lives would be that much more difficult. If we want to kind of see the magnitude of numbers we'd be working with, we can convert our solution, our answer, back into a we can convert our answer that isn't a mixed fraction back into an improper fraction. And so we would have 8 groups of 20, which is 160 plus 19, or an improper fraction of 169/20ths for our answer as an improper fraction. Okay, so again, not the most beautiful numbers to be working with, but again, if it's something you enjoy doing, if you enjoy the challenge of working with bigger numbers, feel free to convert them into improper fractions and deal with them, like example 1. Okay, so 2 different strategies, different situations call for different strategies, but it's something you'll get more accustomed to making the call for. I hope this helps. I hope you guys found this helpful. If you guys have any comments, suggestions, any requests for future videos, please do let me know in the comments below, and thanks for watching.